Something impossible just showed up in our solar system, and it's breaking every rule we thought we knew about how the universe works. On July 1st, 2025, astronomers in Chile spotted an object moving through space at over 130,000 miles per hour. At first, they thought it was just another comet, but within days, they realized this wasn't from our neighborhood. This thing came from outside our solar system, only the third interstellar visitor we've ever detected. They named it 3I divided by Atlas. But here's where it gets weird. Really weird. When scientists started analyzing its chemistry, they found something that should not exist in nature. When they looked at its trajectory, the timing made no sense. And when Mars spacecraft got close enough to photograph it during its closest approach in October, the data they collected changed everything we thought we understood about what travels between the stars. Some of the world's top scientists are now asking a question that sounds like science fiction. What if this isn't a comet at all? Let me show you why this object has the entire astronomical community completely baffled, and why what happened when it passed Mars might be the most important discovery of our lifetime. Before we dive into the Mars data that's causing all this controversy, you need to understand just how strange this visitor really is. Because 3I divided by Atlas isn't just unusual. It's impossible in ways that challenge the basic laws of planetary formation. Let's start with where it came from. Most comets in our solar system formed about 4.5 billion years ago, around the same time as Earth and the other planets. They're leftovers from when our sun was born. We understand them pretty well. We know what they're made of, how they behave, how they formed. But 3I divided by Atlas didn't form here. Based on its velocity and the direction it's traveling through our galaxy, scientists calculated that this object likely comes from something called the Milky Way's thick disk. That's a region of stars that form during what astronomers call cosmic noon, a period between 9 and 13 billion years ago when our galaxy was young, violent, and pumping out stars at an incredible rate. Think about that for a second. This object is potentially older than our entire solar system, older than Earth, older than the Sunday. It was already ancient and drifting through space billions of years before our planet even existed. We've never observed anything this old up close. Ever. It's like finding a message in a bottle that's been floating through the ocean for twice as long as the ocean has existed. Whatever secrets this thing holds, they're secrets from a time when the universe looked completely different than it does today. But here's what really caught everyone's attention. The way it moves doesn't match anything we've seen before. Previous interstellar visitors like Oumuamua back in 2017 and Comet Borisov in 2019 came screaming into our solar system at steep angles. They flew through at weird trajectories that made it obvious they didn't belong here. They were clearly just passing through. 3I divided by Atlas is different. It approached our solar system almost parallel to the plane where all our planets orbit, only tilted about 5 degrees. And it's traveling in retrograde, meaning it's going the opposite direction from how everything in our solar system naturally moves. This trajectory is really unusual. It suggests this object shares something called a dynamical signature with those ancient thick disk stars, the ones that formed when the galaxy was still settling down from its chaotic early years. But there's something else about this trajectory that's making people nervous. Something we'll come back to. Because when you combine this unusual orbit with the timing of when it reached its closest point to the sun, things start looking less like coincidence and more like something else entirely. Now let's talk about what this thing is made of, because this is where the word impossible starts showing up in scientific papers. In early August 2025, the James Webb Space Telescope turned its incredibly powerful instruments toward 3, I divided by Atlas. What it found shocked everyone. Normal comets are basically dirty snowballs. They're made mostly of water ice with some dust and rock mixed in. When they get close to the sun, the water starts evaporating, creating that classic tail we all recognize. Sure, comets have other stuff too. Carbon dioxide, methane, ammonia. But water is always the dominant ingredient, not this one. 3I divided by Atlas has a carbon dioxide to water ratio of about 8:1. Let me say that again. For every 1 part water, there are 8 parts carbon dioxide. The composition breakdown is insane. 87% carbon dioxide, 9% carbon monoxide, only 4% water. This is virtually unprecedented. We've never seen anything like this in any comet from our solar system, not even close. Why does this matter? Because it tells us this object formed under completely different conditions than anything in our neighborhood. The chemistry is all wrong for our solar system. It suggests formation environments that we don't fully understand. Places where carbon chemistry dominated in ways that just don't happen around here. This bizarre composition also gave 3I divided by Atlas another weird ability. Most comets only become active when they get relatively close to the sunday, usually around 3 astronomical units away. That's 3 times the distance between Earth and the sunday. That's when they warm up enough to start releasing gas and forming their tails. 3I divided by Atlas started becoming active at 6.5 astronomical units. That's roughly the distance of Jupiter, way farther out than any normal comet would activate. Why? Because carbon dioxide sublimates at much lower temperatures than water ice. This thing was already spewing gas and lighting up when it was still in the outer solar system, in regions so cold that water would be frozen solid. NASA's Test Space Telescope actually caught this early activity completely by accident. Between May 7th and June 2nd, 2025, before 3I divided by Atlas was even officially discovered, TESS was scanning a section of sky and captured this object gradually brightening as it approached the sunday. Scientists only realized what they were looking at after the comet was discovered weeks later. So we have an object that's potentially 10 billion years old, traveling on a trajectory that matches ancient galactic stars, made of chemistry that shouldn't exist in our solar system, and active at distances where it has no business being active. Already, you can see why astronomers were fascinated. But we're just getting started, because what came next made people start questioning everything. In August 2025, the Very Large Telescope in Chile trained its spectroscopic instruments on 3I divided by Atlas. Spectroscopy is how we figure out what things are made of by analyzing the light they emit or reflect. Different elements create different signatures in the light spectrum. It's like a fingerprint for chemistry. What they found was geochemically impossible. The comet was producing abundant nickel vapor, about 5 grams per second. That might not sound like much, but for a comet, it's a lot. Metallic emissions from comets aren't super rare. Sometimes you see iron, nickel, sodium, other metals getting released as the comet heats up and complex molecules break down. But here's the thing. Nickel and iron are always found together in nature. Always. They're formed together during stellar nucleosynthesis. When stars explode or fuse atoms in their cores, nickel and iron are created in the same processes. Every asteroid we've ever studied, every meteorite that's fallen to Earth, every comet we've analyzed has these metals in predictable ratios. If you find nickel, you find iron. That's just how the universe works. Except here. 3I divided by Atlas was pumping out nickel with almost no detectable iron. The spectroscopic signature showed massive amounts of nickel and essentially none of the iron that should absolutely be there if this was a natural process. Scientists don't have a good explanation for this. The leading theory is that maybe, somehow, the conditions where this object formed were so exotic that nickel and iron got separated. But nobody can explain how that would actually work. The physics don't really support it. Here's where things get uncomfortable for a lot of astronomers. There is one way to separate nickel from iron: industrial refining. Specifically, something called the nickel carbonyl process. It's a technique humans use to purify nickel by reacting it with carbon monoxide, creating a gas that can be separated from iron and other impurities. The gas composition of 3I divided by Atlas includes massive amounts of carbon monoxide, and it's releasing nickel without iron in a way that resembles an industrial purification process. Now, before anyone gets too excited or worried, let's be clear. Most scientists think there's probably a natural explanation we just haven't figured out yet. The universe is full of weird chemistry we don't understand. Just because something looks artificial doesn't mean it is. But this observation got the attention of Harvard astrophysicist Avi Loeb. You might know him as the scientist who suggested that Oumuamua might be an alien probe. Controversial guy. Most astronomers think he jumps to conclusions too quickly, but even his critics admit he asks interesting questions. And when he and his team looked at all the data on 3I divided by Atlas, they published a paper suggesting we should at least consider the possibility that this object might not be natural. They were careful to call it a thought experiment, a way to explore what artificial signatures might look like. But they laid out a case that's hard to completely dismiss. Let's look at what they found. First, there's the chemistry we just talked about. Nickel without iron. Carbon dioxide chemistry unlike anything in our solar system. Complex organic compounds that have somehow survived billions of years in interstellar space. Then there's the timing. 3I divided by Atlas reached its closest point to the sun, called perihelion, on October 29, 2025. On that exact date, from Earth's perspective, the comet was positioned directly behind the Sunday. We couldn't see it. Our telescopes couldn't observe it. There was a period of several weeks where this object was completely hidden from us by the sun's glare. That's not necessarily suspicious by itself. Comets don't care about whether we can see them or not. But combined with everything else, it made some people nervous. Because if you were an interstellar spacecraft trying to enter our solar system undetected, hiding your approach behind the sun would be a pretty smart move. And if you wanted to slow down and enter orbit around the sun instead of just flying through, October 29th would be the perfect time to do it. This is called a solar oberth maneuver. It's a technique where a spacecraft uses the sun's gravity well to change its trajectory. You dive close to the sun, fire your engines at just the right moment, and you can either speed up to escape the solar system or slow down to enter orbit. If 3I divided by Atlas executed a reverse solar oberth maneuver while behind the sun, hidden from Earth's view, it could have changed course in ways we wouldn't detect until it was too late. And when would it arrive in Earth's vicinity after such a maneuver? Late November 2025. Right around now, depending on when you're watching this. Now, Loeb and his colleagues are very clear that this is speculation. They're not saying this is definitely what happened. They're saying the possibility exists, and we should be paying attention. Because if it did happen, we'd want to know. This connects to something called the dark forest hypothesis. It's an idea from science fiction that's gained some traction in scientific discussions about why we haven't detected alien civilizations. The hypothesis suggests that the universe is like a dark forest. Every civilization is a hunter, staying quiet and hidden because making noise attracts attention from potentially hostile civilizations. If you broadcast your location, you might get destroyed by someone more advanced than you. So everyone stays silent, listening in the darkness, hoping not to be noticed. It's a pretty grim view of the universe, but it offers one possible explanation for the Fermi paradox. The question of why we haven't seen evidence of aliens despite the universe being so vast and old. If the dark forest hypothesis is true, then an advanced civilization traveling between stars would be extremely careful about being detected. They'd move quietly, they'd use natural camouflage, they might even disguise their spacecraft to look like natural objects, like, say, comets. Is that what's happening here? Almost certainly not. The universe is strange enough without needing aliens to explain everything. There are probably natural explanations we just haven't thought of yet. But the fact that serious scientists are even discussing this possibility tells you how truly bizarre this object is. Now, let's talk about what happened when 3I divided by Atlas got close to Mars, because this is where the story takes another turn. As 3I divided by Atlas approached the inner solar system in October 2025, Earth-based telescopes lost sight of it due to the sun's glare. This created a huge problem for astronomers who desperately wanted to observe this thing during its most active period. But we got lucky. Really lucky. Mars was in the perfect position. Between October 17th and 29th, as the comet swung around the sun, Mars was only about 30 million kilometers away from it. In cosmic terms, that's basically right next door. And orbiting Mars, we have a fleet of sophisticated spacecraft. Probes from NASA, the European Space Agency, China, and the UAE. All equipped with cameras and instruments designed to study Mars, but capable of turning their attention to other targets. For the first time in history, we had multiple spacecraft with a close-range view of an interstellar object during its closest approach to the Sunday. This was an unprecedented opportunity. The European Space Agency's Mars Express and Trace Gas Orbiter were particularly well positioned. These spacecraft carry instruments designed to analyze the Martian atmosphere and surface, but they work just as well for studying comets. NASA's Mars Reconnaissance Orbiter joined in with its HiRISE camera. This is one of the most powerful cameras ever sent to another planet. It's designed to photograph Mars in incredible detail, capable of resolving features less than a meter across on the surface. When HiRISE turned toward 3I divided by Atlas, it achieved a resolution of about 30 kilometers per pixel. That might not sound impressive compared to what it can do with Mars, but for a comet millions of kilometers away, it's actually remarkable. These became some of the sharpest images ever taken of an interstellar object. China's Tianwen-1 orbiter and the UAE's HOPE probe added their observations as well, providing different viewing angles and wavelengths of data. All told, 5 different spacecraft from 4 different space agencies coordinated to study this visitor during the most critical period of its journey through our solar system. What they found raises even more questions. The images revealed 3I divided by Atlas's unusual tail structure in detail. Most comets develop 2 tails as they approach the Sunday. A dust tail that curves along the comet's orbital path, pushed by the pressure of sunlight, and an ion tail made of charged particles that points directly away from the sun, pushed by the solar wind. Pretty straightforward. The tails always point away from the sun because that's where the pressure comes from. 3I divided by Atlas developed an anti-solar tail, a tail pointing toward the Sunday backwards. How is that possible? The answer has to do with the comet's rotation and the size of its dust particles. The comet appears to have a hardened, radiation-processed crust from billions of years of exposure to cosmic rays in interstellar space. This crust doesn't sublimate evenly. Instead, the sun-facing hemisphere heats up and releases material preferentially from that side. The dust particles being released are also unusually large, hundreds of microns across, much bigger than typical cometary dust. These large particles aren't easily pushed by solar radiation pressure, so instead of being blown away from the sun, they sort of hover and accumulate near the comet, creating this bizarre backwards appearance. It's consistent with an object that spent billions of years in deep space, getting bombarded by radiation, developing a tough exterior completely unlike anything in our solar system. But here's another weird detail the Mars spacecraft picked up. The comet's polarization signature is extreme. Polarization is a property of light that tells us about the structure and composition of the particles reflecting that light. By measuring how light from the comet is polarized, scientists can infer things about the dust grain's composition, size, porosity, and other characteristics. 3I divided by Atlas showed a minimum polarization of negative 2.77%. That's the deepest negative polarization ever measured for any solar system body, nearly twice as deep as any known comet. This suggests dust grains that are fundamentally different from anything we've encountered before, potentially highly porous, icy aggregates with structural properties we don't see in our solar system. The polarization signature most closely resembles certain small trans-Neptunian objects, the frozen bodies out past Neptune's orbit. But even those aren't quite right. This is something else. All of this data from the Mars observations confirmed that 3I divided by Atlas isn't just unusual. It's in a category by itself. Every measurement reveals characteristics that push the boundaries of what we thought was possible for comets. Then the Hubble Space Telescope got involved, and what it found made scientists recalculate everything. After the Mars observations, astronomers used the Hubble Space Telescope to study 3I divided by Atlas as it moved away from the Sunday. Hubble's job was to measure the comet's brightness and how that brightness changed over time, which would allow scientists to estimate its size. They expected it to be small, maybe a kilometer or two across. That's fairly typical for comets, and interstellar objects are generally thought to be on the smaller side. The calculations came back. The nucleus of 3I divided by Atlas is at least 5 kilometers in diameter, possibly larger, and its mass exceeds 33 billion tons. That's huge, way bigger than anyone expected. For context, Oumuamua was probably only about 200 meters long. Comet Borisov was estimated around 1 kilometer across. This thing is 5 times bigger than Borisov and potentially 25 times bigger than Oumuamua in terms of diameter. In terms of mass, it's orders of magnitude more massive. Why is this a problem? Because of statistics. The rate at which we detect interstellar objects depends on how common they are and how big they are. Bigger objects are easier to spot, so we should detect them more often. Smaller objects are harder to find, so even though there are probably more of them, we miss most of them. Based on the detection of Oumuamua and Borisov, astronomers calculated the likely population of interstellar objects passing through our solar system. Their models predicted we should be seeing mostly small objects, with occasional larger ones. But if 3I divided by Atlas is this massive, the statistics don't work anymore. We should have detected thousands of smaller objects before ever finding something this large. The probability of finding a 5-kilometer interstellar object as only our third detection is incredibly low, unless there's something wrong with our assumptions. Either interstellar objects are far more common than we thought, or 3I divided by Atlas represents something fundamentally different from a typical interstellar wanderer. Some scientists suggest this indicates a much higher density of large interstellar objects than our models predict. Maybe planetary systems are more violent than we realized, regularly ejecting large bodies into interstellar space. Maybe there are populations of rogue planets and massive comets drifting between the stars that we've dramatically underestimated. Or maybe 3I divided by Atlas isn't a natural ejected comet at all. Maybe it's something else, something directed, something that chose to come here. That's the explanation nobody wants to say out loud, but it's there, hanging in the background of every discussion about this object. Because when you add up all the anomalies, the pattern becomes hard to ignore. The retrograde orbit nearly parallel to the ecliptic, the timing of perihelion when Earth can't observe it, the impossible chemistry, the industrial-looking metal emissions, the extreme size, the ancient origins from cosmic noon. Any one of these things alone would be interesting but explainable. All of them together in one object starts looking less like coincidence and more like a signature. But a signature of what? Let's step back and look at what we actually know versus what we're speculating about. We know 3I divided by Atlas is real. It exists. Multiple observatories have tracked it. Spacecraft have photographed it. Its trajectory has been calculated. This isn't a mistake or a misidentification. We know it came from outside our solar system. Its velocity and trajectory make that absolutely certain. This thing traveled through interstellar space for potentially billions of years before arriving here. We know its composition is bizarre. The extreme carbon dioxide dominance, the nickel emissions without iron, the complex organic chemistry, these are all measured facts, not speculation. We know it's larger than expected. The mass and size calculations are solid. This is a big object. We know its surface properties are unusual. The polarization data, the backwards tail, the hardened crust, all of this comes from direct observations. Those are the facts. Everything else is trying to figure out what those facts mean. The conventional explanation is that 3I divided by Atlas is a comet from another star system that formed under exotic conditions we don't fully understand. Maybe its parent star had unusual composition. Maybe it formed in a region of its solar system where carbon dioxide ice was more common than water ice. Maybe the lack of iron has some complex geochemical explanation involving minerals we haven't considered. This is probably the right explanation. The universe is full of chemistry and physics we're still figuring out. Strange doesn't mean artificial. It just means strange. But there's a reason why even skeptical scientists are at least acknowledging the other possibility. Because if you were an advanced civilization traveling between stars, if you wanted to explore another solar system without being immediately obvious, this is pretty close to what it would look like. You'd disguise your probe as a comet. Natural objects that are expected to occasionally enter solar systems from interstellar space, you'd use the trajectory and timing to minimize observation windows during critical maneuvers. You'd keep your presence ambiguous enough that any intelligent life in the system would debate whether you were natural or artificial. If you subscribed to the dark forest philosophy, if you believed revealing yourself was dangerous, you'd want your exploration to be subtle. Deniable, something that could be written off as just another weird comet. And you'd want to collect data, which means you'd want to get close to the interesting planets. Like Mars or Earth. Is that what's happening? We don't know. We probably won't know for a long time, if ever. But the fact that we're even having this conversation tells you something important. We're at a point in human history where detecting artificial objects from other civilizations is no longer pure science fiction. We have the technology to find them, study them, and at least ask the right questions. Whether 3I divided by Atlas is natural or not, it represents a new era in astronomy. The era where interstellar visitors are something we can actually observe and analyze in detail. Now let's talk about what this object might tell us about the early universe. Because even if it's just a comet, it's the most important comet ever found. Scientists are particularly interested in whether any surprises emerge during this final phase. Will the comet show any unexpected behaviors as it leaves? Will its trajectory remain consistent with a natural orbit? Or will there be any anomalies that might suggest course corrections? That last question is the one nobody is officially asking, but everyone is thinking about. If 3i divided by Atlas were to make any trajectory changes that couldn't be explained by gravitational forces and outgassing, it would be a game changer. It would be the first definitive evidence of artificial control. Most scientists think that's extremely unlikely. But after everything else we've seen with this object, nobody is ruling anything out completely. Beyond JUICE, there's another development that makes the 3i divided by Atlas story even more significant. The Vera Rubin Observatory is scheduled to begin full operations soon. This facility in Chile has a mirror over 8 meters across and a camera with 3.2 billion pixels. It's designed to survey the entire visible sky every few nights, creating an unprecedented database of moving objects. When Rubin comes online, we're going to start detecting interstellar objects much more frequently. Current estimates suggest we might find hundreds per year, maybe more. 3i divided by Atlas will be remembered as the benchmark, the first interstellar visitor we studied in comprehensive detail with multiple spacecraft, the template against which all future discoveries will be compared. Each new interstellar object will be evaluated against what we learned here. Is it normal like Borisov, weird like Oumuamua, or completely unprecedented like 3i divided by Atlas? And each new detection will help answer the questions raised by this object. Is 3i divided by Atlas a rare anomaly? Or does it represent a common class of interstellar traveler that we just haven't sampled enough to understand yet? Over the next decade, we'll build up a statistical sample of interstellar objects. We'll learn what's typical and what's exceptional. We'll get better at distinguishing between natural and potentially artificial signatures. Maybe we'll find more objects with impossible chemistry and convenient timing. Or maybe 3i divided by Atlas will stand alone as a unique mystery. Either way, the age of interstellar astronomy has truly begun. We're no longer just looking at distant stars and planets. We're studying physical objects from other star systems. Touching, even if only with cameras and spectrometers, materials from across the galaxy. That's a profound shift. It changes how we think about our place in the universe. So, where does this leave us? What should we take away from the 3i divided by Atlas story? First, the universe is stranger than we give it credit for. Even if this turns out to be a completely natural comet with weird but explainable chemistry, it demonstrates that our theories of planetary formation and cometary science still have major gaps. We don't understand everything, not even close. The fact that an object's composition can be so radically different from everything in our solar system shows how diverse planetary formation processes can be across the galaxy. Every star system is its own unique laboratory, producing materials and objects shaped by that system's specific conditions. This has implications for understanding planets in general, including potentially habitable ones. If chemistry can vary this wildly, then the ingredients available for life might also vary in ways we haven't considered. Maybe carbon dioxide worlds are more common than we thought. Maybe there are entire classes of planets with chemistry we've never imagined. Second, we live in an era where we can actually detect and study interstellar objects. This is new. 20 years ago, it was purely theoretical. Now, it's routine. We've found 3 in 8 years. With better telescopes coming online, we'll find hundreds more. This is going to revolutionize our understanding of what's out there between the stars. We've always thought of interstellar space as empty void, but it's not empty. It's full of wanderers, Kume, asteroids, maybe even rogue planets, all drifting through the darkness, carrying information about their origins. Some of these objects might be billions of years old, samples from the early universe. Others might have been ejected from their home systems recently. Each one is a data point. Each one tells a story. Third, and this is the uncomfortable one, we now have to seriously consider the possibility that some of these objects might not be natural. That doesn't mean 3i divided by Atlas is artificial. It probably isn't. But it means we can't just assume anymore that every weird object is natural without actually checking. If there are other technological civilizations in the galaxy, and if they explore using probes, then statistically, we should eventually detect one. Maybe not soon, maybe not in our lifetimes, but eventually. The question is whether we'll recognize it when we see it, or whether it'll be ambiguous enough that we'll debate it forever. Never quite sure. 3i divided by Atlas might be that object. Or it might just be preparing us for when we do encounter the real thing. The scientific process will continue. More papers will be published. More data will be analyzed. Some scientists will argue for natural explanations. Others will keep asking whether we're missing something obvious. That's how science works. That's how it should work. You don't jump to conclusions. You gather evidence. You build models. You test hypotheses. You stay open to possibilities while demanding rigorous proof. But here's what we know for certain. Something extraordinary traveled billions of years across the galaxy and passed through our solar system in 2025. Something with chemistry we've never seen, behavior we can't fully explain, and origins from a time before our sun existed. Whether it was sent, or whether it wandered randomly, it found us. And for a brief moment in cosmic history, humanity got to observe a visitor from cosmic noon, a messenger from the ancient galaxy. We photographed it. We measured it. We analyzed its chemistry and tracked its motion. We did everything we could to understand it in the short time it was accessible to us. Now it's leaving, heading back out into the dark, carrying whatever secrets it holds back into the depths of interstellar space. Will we ever know what it really was? Maybe, maybe not, but we'll remember it. The third interstellar visitor, the one that changed everything. The one that made us ask bigger questions about what might be traveling between the stars. And maybe, decades from now, when we've detected hundreds more interstellar objects, when we've built up enough data to really understand these travelers, we'll look back at 3i divided by Atlas and finally understand what we saw. Or maybe it'll remain a mystery forever. A strange visitor that came and went, leaving more questions than answers. Either way, it reminded us of something important. The universe is vast. It's old. It's full of wonders we're only beginning to discover. And every once in a while, something from out there comes here, giving us a glimpse of what else exists in the cosmic dark. 3i divided by Atlas was that glimpse. And it changed how we see the universe forever. The sky isn't empty. Things are moving through it. Ancient things, strange things, things that challenge everything we think we know. And now we know they're out there, traveling between the stars. Some heading away from us, others perhaps heading toward us even now. The question is what we'll do when the next one arrives. Will we be ready? Will we have the right instruments, the right questions, the right minds focused on the mystery? Because if 3i divided by Atlas taught us anything, it's that we need to be paying attention. The universe is trying to tell us something, Maybe it's just teaching us about physics and chemistry we don't understand yet. Or maybe it's introducing itself slowly, carefully, in ways that could be mistaken for natural phenomena if we're not looking closely enough. We don't know which it is, but we're watching now. We're listening. We're building better telescopes and sending more spacecraft and asking harder questions. And when the next interstellar visitor arrives, we'll be ready to study it, to photograph it, to measure it, to understand it. Because that's what humans do. We explore, we question, we reach out into the unknown and try to make sense of what we find there. 3I divided by Atlas came from cosmic noon, from a time when the galaxy was young and violent and bright with newborn stars, from a place and time we can never visit. But for a few months in 2025, we got to study a piece of that ancient past. We held it in our instruments and cameras, if only for a moment. We learned from it. We were changed by it. And that's worth something. That's worth everything, actually. Because understanding where we came from, understanding what else is out there, understanding our place in this vast and ancient galaxy, that's the deepest question humanity has ever asked. 3I divided by Atlas didn't answer that question completely, but it gave us clues. It showed us that the universe is more diverse, more complex, more surprising than our theories predicted. It reminded us that we're still learning, still discovering, still at the very beginning of understanding the cosmos we inhabit. Let me bring this back to something more concrete, something you can actually think about and process. The data collected from 3I divided by Atlas fills thousands of pages of scientific papers, spectrographic analyses, trajectory calculations, compositional breakdowns, polarization measurements. It's overwhelming. Most people, even most scientists, can't absorb all of it. But here are the key takeaways that matter. We found an object from outside our solar system. That alone is historic. Every time it happens, it expands our understanding of what's traveling through interstellar space. This object is old, potentially 10 billion years old. It formed when the universe looked completely different. When our galaxy was in its youth, that makes it the oldest thing we've ever examined up close, older than anything in our solar system by billions of years. Its chemistry is wrong, not slightly unusual. Fundamentally different from anything we've seen. Carbon dioxide where there should be water. Nickel without iron. Organic compounds that shouldn't have survived. This tells us that planetary formation can produce outcomes wildly different from what we observe locally. Its behavior is suspicious. The trajectory, the timing, the activity patterns all raise questions. Most of those questions probably have natural answers, but the pattern of anomalies is striking enough that serious scientists are at least considering alternatives. The Mars observations were unprecedented. We've never had spacecraft positioned to observe an interstellar object during its most active phase. The images and data collected represent a quantum leap in our ability to study these visitors. Its size surprised everyone. At over 5 kilometers across and 33 billion tons, it's much larger than expected based on previous detections. This suggests either we've been lucky or there's something different about 3I divided by Atlas. And now it's leaving. Within a year, it'll be too far away to study effectively. Within a few years, it'll exit our solar system entirely. We'll never see it again. It came from the depths of space, passed through our neighborhood briefly, and now returns to the darkness. That's the story. That's what happened in 2025. But the implications ripple forward. Every future interstellar detection will be compared to this one. Every weird object will make us ask if it's another 3I divided by Atlas. Every trajectory anomaly will make us wonder. We're entering an era where these questions are normal. where detecting visitors from other star systems is routine, where the possibility of artificial objects needs to be seriously considered alongside natural explanations. This changes astronomy. It changes how we think about what's out there. It changes the questions we ask. Are we alone? We still don't know. But we're getting better at looking for the answer. We're developing the tools, the methods, the frameworks to distinguish between natural and artificial, to recognize signatures that might indicate intelligence versus random chemistry. 3I divided by Atlas pushed that process forward significantly. Whether it's natural or not, it showed us what an ambiguous case looks like. It showed us how hard it is to be certain, how easy it is to see patterns that might not be there, but also how important it is to stay open to possibilities. The universe is under no obligation to make sense to us. It doesn't care about our theories or our expectations. It just is. And sometimes it throws something at us that doesn't fit our models. When that happens, we have two choices. We can force it into our existing frameworks, bending the data until it fits what we want to believe. Or we can let it challenge us, let it expand our thinking, let it show us that we don't know everything. 3I divided by Atlas is challenging us, making us question assumptions, making us wonder. That's uncomfortable. Science doesn't like uncertainty. We want clear answers, definitive explanations, neat categories where everything fits perfectly. But the best discoveries come from things that don't fit, from observations that break the rules, from mysteries that force us to think differently. Maybe 3I divided by Atlas is one of those discoveries. Maybe decades from now, scientists will look back and realize this was the moment everything changed. The moment we first detected something that made us fundamentally reconsider what's possible. Or maybe it'll be a footnote, an interesting anomaly that turned out to have a boring natural explanation. A strange comet from a strange place with strange chemistry. Time will tell. More data will come in. More interstellar objects will be found. Patterns will emerge, or they won't. But right now, in this moment, we're living through something historic. We're witnessing a mystery unfold in real time. And that's rare. That's special. Most cosmic mysteries take place over timescales we can't observe. Galaxies colliding over millions of years. Stars being born and dying over billions. We can only see snapshots, frozen moments that we try to piece together into a narrative. But 3I divided by Atlas happened fast. Discovery in July, peak activity in October. Mars observations, analysis, debate. All within a few months, we got to watch the whole story unfold. And the story isn't quite over. The final chapter is being written right now as JAICE prepares for its March observations. As scientists continue analyzing the data already collected, as new papers get published arguing different interpretations, by this time next year, we'll know more. Not everything, but more. We'll have a clearer picture of what this object was, where it came from, what it means. Until then, we're left with questions. Beautiful, frustrating, exciting questions. What was 3I divided by Atlas? Where exactly did it come from? How did it get its impossible chemistry? Why was its timing so convenient? What was it doing during those weeks when Earth couldn't see it behind the sun? Are there more like it out there? Are we about to discover that interstellar space is full of these ancient travelers, each one carrying secrets from different eras in different parts of the galaxy? And the biggest question? The one that hangs over everything else. Are we alone? 3I divided by Atlas doesn't answer that, but it makes the question feel more urgent, more real. Because if the answer is no, if there are others out there, this is probably what first contact would look like. Not flying saucers landing on the White House lawn, not radio signals announcing themselves clearly, but something ambiguous, something that could be natural or could be artificial, something that makes us argue and debate and wonder, something exactly like 3I divided by Atlas. Whether it's the real thing or just practice for when the real thing arrives, we needed this. We needed to be challenged. We needed to confront our assumptions. We needed to start taking seriously the idea that we might not be alone. Because if we are alone, if life is so rare that we're the only ones in this vast galaxy, that's one kind of profound. It means we're precious, unique, irreplaceable. But if we're not alone, if there are others out there, if some of them have been around long enough to travel between the stars, that's a different kind of profound. It means we're part of something bigger, part of a cosmic community, part of a story that's been unfolding for billions of years. Either way, the truth changes everything about how we see ourselves and our place in the universe. 3I divided by Atlas brought that truth closer, made it feel more tangible, more immediate. And now we wait, we watch. We keep building better telescopes and sending more spacecraft and asking harder questions. Because somewhere out there, right now, there might be another interstellar visitor heading our way. Another ancient traveler from cosmic noon. Another messenger from the depths of space. And when it arrives, we'll be ready. We'll study it. We'll learn from it. We'll add it to our growing catalog of interstellar objects. And maybe, just maybe, one of them will give us the answer we're looking for. The definitive proof that we're not alone. Or the definitive proof that we are. Until then, we have 3I divided by Atlas. The visitor that changed everything. The comet that might not be a comet. The mystery that refuses to be solved. It came from 10 billion years in the past, from the thick disk of our ancient galaxy, from conditions we can barely imagine. It survived the journey through interstellar space, through the cold and the radiation and the endless darkness. It found our solar system. It dove close to our Sunday. It let us observe it, study it, photograph it. And now it's leaving, carrying its secrets back into the void. But it left us something valuable. Not just data, though the data is incredible. Not just images, though the images are historic. It left us wonder. It left us questions. It left us knowing that the universe is stranger and more surprising than we ever imagined. And in the end, maybe that's the most important discovery of all. The universe doesn't want us to be comfortable. It doesn't want us to think we have everything figured out. It keeps throwing surprises at us, keeps challenging us, keeps showing us how much we still have to learn. 3I divided by Atlas is one of those surprises. A gift from the cosmos. A puzzle wrapped in a mystery, wrapped in an enigma. We may never fully understand it, but we'll never forget it either, because it showed us what's possible. What might be out there? What could be traveling through the darkness even now, heading our way? The age of interstellar astronomy has begun, and 3I divided by Atlas was our initiation. Our first real test. We passed. We rose to the challenge. We observed, analyzed, debated, and learned. And we're ready for whatever comes next, because now we know. The space between the stars isn't empty. It's full of travelers, full of mysteries, full of possibilities. Some of them are heading our way. Some of them might already be here. And humanity is finally ready to notice, ready to study them, ready to ask the biggest question of all. Are we alone? 3I divided by Atlas whispered an answer. but the whisper was too quiet to hear clearly, too ambiguous to be certain. So we'll keep listening, keep watching, keep waiting for the next visitor. And maybe someday we'll get a clear answer, one way or another. Until then, we have the memory of that strange visitor from cosmic noon, the object that didn't fit, the comet that challenged everything. 3, I divided by Atlas, the visitor that changed astronomy forever. If you want to learn more about interstellar objects and stay updated on new discoveries, subscribe